Welcome to the Epic Web3 podcast. My name is Alex. I'm CEO and co-founder of Epic Web3. We make professional events for Web3 builders all over the world. And my co-host today is Andy, founder of The Rollup, the education and media company in DeFi. Hi, Andy.
I'm ready to hit Nick with some tough questions. Nick, we got a lot going on in the modular space.
Yeah.
I'm ready.
Our guest today is Nick Dodson, CEO and co-founder of Fuel. Fuel is one of the most powerful L2 technologies for scaling Ethereum. Nick, how's it going?
It's going great.
Let's start with Fuel itself. So, Fuel has been in the industry for quite a while already, and you have made several pivots, I think. So, what is basically Fuel? What Fuel is now? What are you doing now?
Yeah, so when we started, initially the project started with just me trying to build a wallet. So unfortunately, that's where the rabbit hole began. And it was just trying to build a wallet that would allow basically just secure and cheap transactions on Ethereum. So the journey sort of started there. And then that basically led to understanding and exploring rollups and realizing that rollups were actually a great technology to support effectively that, like just from more of like a first principles sort of thinking, and then basically from that, we built out what is Fuel V1, which was effectively and still is the only actual rollup on Ethereum. There might be one or two others depending on how you look at it, but basically the only one. And the idea of a rollup was that you could build a piece of technology on top of Ethereum that would allow it to scale, but inherit the security, the underlying security of Ethereum. So, and basically, if it's an optimistic rollup, it would just need what's called an honest minority assumption to be this inherited system. So, meaning only one person needs to check it in order for it to actually inherit the security of Ethereum. So basically, we kind of led off the charge with deploying effectively the first and still only actual optimistic rollup in the space. And the definition there being that there was no multi-sigs, there was no upgrade keys. It was all published basically like hardware to Ethereum. It inherited the security of Ethereum itself. And a while ago, I mean, I don't know how defended the network is now, but a while ago, it also defended itself from an attack from the L2B team, which was pretty cool. So basically, that was Fuel V1. And the idea there was not only to build a roll up and actually deploy it. We did that in like December 2020, but was also to explore different kinds of models to process blockchain transactions. So effectively, in our first roll up, we used the UTXO model, which gave us a lot of really great properties for scaling blockchain. The reason why we did that was because the whole reason why we need rollups in the first place is because the execution architecture of Ethereum is highly constrained. So the EVM is unfortunately not a very good machine to scale blockchain. It's very bottlenecked. And so we, instead of recreating the same problem, just putting it in a rollup, we decided that we would do a different execution architecture. And in doing so, really try to holistically address the issues that Ethereum was facing from a scalability perspective, and not just recreate the same problem again, just in a different layer of abstraction with less security, arguably, and more issues because it's now another execution layer. So, yeah, that's why we basically went with a different model and approached the rollup design the way we did. What Fuel is now has evolved significantly from just UTXOs and simple transfers and rollups. So I think the easiest way to describe what we're building now is that Fuel is really an operating system for rollups. So it's a blockchain operating system, and in a sense, it resolves a bunch of different issues we have when building blockchains. So not only does it resolve performance and scalability, but it also solves other things like interoperability and state, which are really plaguing the existing high performance architectures in the space right now. And it also resolves a bunch of other things, such as more nuanced and intimate issues, like the way ABI is constructed, the way indexing is done, the way all the tooling is built, the way the languages work with the virtual machine. So it really tries to holistically address pretty much every problem that we encounter with blockchains today as developers or advocates. And essentially, Fuel is looking to really holistically address all these concerns and also not take any shortcuts. So hence why it's taken a while. Yeah.
Okay. You have your own programming language, I suppose, called Sway, right? So can you tell a little bit why did you decide to develop it? Why not just use something which is already existent?
Yeah. So I think in terms of blockchain programming, at the time when we started the project, really your only option was effectively Solidity. There was a few others, but for blockchain programming in general, that was basically the predominant language. The issue is that Solidity and the existing blockchain languages were either not maintained or were pretty bad, quite frankly. Solidity's gotten us really far as a community. I've been using it almost since it started. But basically, Solidity has a lot of shortcomings. It was handed off to multiple different teams. It was designed in a very fragmented way. And it was launched very early to solve a problem, which was how do we build things on Ethereum? But it wasn't really holistically designed for either security or just application design, safe application design in general. And so Solidity was kind of not a great choice if you really want to solve all the different problems of blockchain. Similarly, all these new systems languages were also coming out. Rust was getting more popular, and there's always C in other languages. And the reason why we didn't pick those is because Rust and other languages are not really designed for blockchains. They're designed to target CPUs, particularly. And sometimes they're good at targeting GPUs and specialized chips. The issue is that Rust and the whole tool chain is usually designed to target those environments and not designed to target a blockchain. So first of all, when you use them as a dev, it doesn't feel good. It feels completely weird to use a systems language to target a blockchain. And then secondly, the entire tool chain is built for targeting a CPU. So most of the optimizations, most of the checks, most of the ideas are really designed for CPU caching and other things like that. And on a blockchain are completely useless. So you have a tool chain that isn't designed for that. And then you have a language that isn't really designed for that. And even though Solidity might be bad, you basically would prefer that because at least that tool is designed to target the system you're using. So basically, because we made the decision to do our own virtual machine to solve the problems I just mentioned, we also wanted to do our own language that would target that machine, but would also be a sort of general purpose language for all blockchain. So Sway, and we'll run this campaign next year, but basically we'll invest millions into security and also millions into making it the best arbitrary blockchain language that exists for targeting blockchain. So you'll be able to target, all the different various general purpose runtimes, but in a blockchain context, and also all the blockchain runtimes in blockchain context. So basically, blockchains have weird things. They have weird properties, and you want the language to be able to understand those properties. But you also want, if you're going to learn a language, you better learn one that works for a lot of different things, and not just for our current very niche virtual machine. So those are some motivating reasons why we designed Sway.
And the idea of being an operating system more or less comes from the combination of the virtual machine layer with Sway as the language. But that's it. That's able to be that's compatible with like RAS providers with data availability layers. It's compatible with different stacks. It's an operating system because you can build with it anywhere. Kind of talk to us a bit about how you see that, or kind of how that works.
Yeah. So, I mean, in the space, we sort of call these things like stacks or things like that too. Like, I think they're kind of interchangeable words, but basically, what the Fuel VM does is it solves a lot of the execution issues of blockchain, but still doesn't lose a very high performance general purpose virtual machine design. So imagine using the simplest, best virtual machine you could maybe think of. Maybe I call that RISC-V because I don't like WASM. And then basically make it oriented around the things we really do in blockchain. So you can think about the Fuel VM that way, in the sense of, what if someone thought of all these different various problems that blockchains have, considered that in the blockchain virtual machine design, but also didn't leave you hanging with a virtual machine that's really bulky or baggy like the EVM. So effectively, in that sense, the virtual machine can run anywhere. So whether it be, in settings where it's posting data to Celestia or posting data to Ethereum, it can post data wherever you like. It can settle wherever you like, and as well, it is designed to run in different settings. So whether you have a low node requirement setting or you have a high node requirement setting, it can handle both. It can handle extremely high TPS on very low grade hardware, all things considered, and basically give you, again, these properties that you're looking for longer term, like a more sustainable design and one that's more interoperable, better on state, etc. So that's sort of some of the design. Yeah.
Yeah, I'm curious, kind of deeper on that subject. So we have a operating system, a virtual machine that is able to be kind of interoperable with whatever. Celestia's term to build whatever. I kind of like that. So we have Fuel VM anywhere. Fuel VM can be on any type of modular role effectively. But how do we? This is more getting into like the interop between different VMs, which is something that's interesting to me. So I know that, like, for example, Movement has like an EVM compiler that you're able to kind of bring data and kind of tooling from EVM devs can kind of deploy simultaneously on both. So that's one example that I'm curious about, how Fuel VM based rollups would interact with EVM based rollups, and then also how do Fuel VM based rollups interact with non EVM based rollups, like a Move VM based rollup, a EVM based rollup, and a Fuel VM based rollup are in a horizontal line, but how do they interconnect, either surpassing EVM or through EVM?
Yeah. So there's definitely a few things there. So the first thing is that, on the point of like transpilers or tooling for different things, I think a lot of different ecosystems tried to do this, but I don't actually think it matters. And I also don't think you should use it, because transpilers basically shouldn't be trusted. They're a whole set of really complex tooling that would probably take years to really effectively audit and figure out. As well, really understanding the compiler tool chain is like very important to designing applications. And, you know, magically sticking an Ethereum app in a non EVM setting is probably not the best idea. You can do anything. You can do absolutely anything you want. It's just, the question is, do you really want to do that, or why wouldn't you just write it and move? Like, is it really going to take that long to write your app? Like, just take the logic and write it and move? Probably not. It's probably much better to do that. So I don't really think that's very effective. That being said, Fuel will have transpilers to go from Solidity and Sway, so the logic can be interchanged. But we'd only recommend that as a way to view what your application would look like in Sway, and not to actually use it. Secondly, we can write contracts in Fuel that are effectively an EVM emulator. But we've sort of hesitated on doing that because, again, like, it sort of takes away the magic of actually leveraging all the different things we can do with Fuel. And using Solidity as a starting point is already a bad starting point for an experience. So basically, it doesn't matter how you want to band-aid it or package it up or do something. All of that stuff won't really matter. I think what's ultimately going to matter is, for your project, is this the right architecture to, scale, interoperate, build out your project, whether it's in an app form or a roll-up form, and does this give you the properties you're really looking for? And ultimately, that doesn't need to be an EVM anymore. It doesn't need to be Solidity anymore. So I think you have to kind of move beyond that. But additionally, when it comes to the actual architectures themselves and interoperating them, So the Fuel VM itself is constructed in such a way that basically introspection, so taking a look at the block itself, cryptographically speaking, is the best in the entire space. So our VM is designed for introspection from the beginning, which means that with a very light Merkle proof, a few depths in size, you can take a look at anything that's happened in each block just from the block header. So this is extremely light in comparison to, say, the EVM, where you have to descend enormous depths just to understand things like state or receipt routes and stuff like that within the block. And so because of the way we designed the Fuel VM, it's actually perfect for interoperating it with other chains. Now, for us to introspect an EVM chain, you run into all the same problems that every EVM chain does. Hence, they need complex bridges with a lot of faults or ZK to try to bridge the gap. Whereas with the Fuel VM, you don't need any of that. Just need a light Merkle proof, and you can take a look at anything that goes on in our virtual machine. So we plan to leverage this in a much broader way with other network architecture that we have. But essentially, you could think of it as for Move, which I'm less sure about, but particularly EVM or other VMs that are very high performance. I won't name any names. It's extremely hard to cryptographically introspect them. And that means that bridging is a giant mess and typically can't be trust minimized. So for Fuel, if you're interoperating, for example, two Fuel VMs together, it literally can be done almost in the same block with just a Merkle proof on both sides and a smart contract with no multi-sigs, because effectively they can easily introspect each other so long as they share one common layer. So be it settlement or DA or our sequencing, effectively you can interoperate them really quickly. So it's a whole other caliber of design for blockchain in general.
And just one last thing on that, and then I think Alex has a couple ones probably as well. Does that design basically? I mean, it kind of mimics like what a light client would do for crushing interop, and also kind of is similar to what a light client would do on a data availability sampling layer. And those often lower the costs of the function. Does that also, so when a transaction is sent, the first thing it gets to an operator, this is the Fuel VM, because of the architecture, is the cost that you have of execution because of this kind of, like, for lack of a better term, light verification or less verification, does that drive cheaper costs for execution? And then if 100%. So, like, do you guys capture extra like revenues or potential fees from that, or is there subsidization, or kind of what do you?
Yeah. So definitely, if you're designing a blockchain, you want really, really good light client support. And so because we've designed Fuel for both fraud proving and for light clients, it means that introspecting all the different aspects of execution, state, or transactions is really, really light. So yes, it's exactly that. The difference would be that for a Fuel light client, it could basically exist on a blockchain, even because it's so light, and introspecting any part of it is extremely easy. It's just something that could be done even on the EVM. So basically, we have some of the best and most performant light client designs out there that are also the most rich and useful. And light clients will be part of every aspect of our architecture. So every wallet will run one. Every phone that uses it will run it. Every person pinging an SDK will run it because it's so light. It's basically as light as anything, the lightest piece of software you could imagine. So in that sense, because of that and other things that we've done to the design, it'll allow you to have full verified communication between the RPCs and the actual clients themselves, but also allow for really intense interoperability. Yeah.
Nice. I read about Fuel VM a little bit, and I read that it is register based instead of stack based. Can you elaborate a little bit on that so that I understand?
Yeah, for sure. So blockchain virtual machines are strange, which is why, again, you probably don't want to use Rust to target them. Some interesting properties that really, if you were designing a virtual machine that you need to know about, are that basically you need to meter every operation, which ends up causing a lot of weird issues when it comes to how you design programs. So ideally, you want your virtual machine to use far less opcodes, because less opcodes means less metering per operation. So surprisingly, for a blockchain, using something with more operations is actually more efficient than using something with less. So if you use a RISC architecture, right, that uses a few instructions, it's actually going to end up costing you a lot more, because you have a lot more gas metering, because you have to do more instructions to achieve the same behavior. So it basically throws a huge curveball into designing a system in general, because you're now designing around reducing operations and gas metering, and also things like state and these other problems we suffer in blockchain, and not necessarily like making something that looks nice, or like just a few operations. So unfortunately, that throws out pretty much all your reduced instruction set architectures like MIPS and RISC, because you actually want more operations. You actually want something more like x86 in terms of instruction set versus ARM, which is very strange, but that's just the nature of blockchains. So in that sense, it's really interesting to design around that problem. So with the Fuel VM, register virtual machines typically use way less operations to achieve the same behaviors. So in that sense, that's why you want to pick a register machine versus a stack-based. And that was still a theoretical paper that proved that, but nonetheless, it's still everything we do with the Fuel VM is designing around that property. So yeah, that's some color there, basically.
Okay. And what do you think about the future of VMs in general? There are a lot of different VMs now in the market. So where do you think it all goes? Is there going to be a bunch of different solutions in different areas, or will there be a all-in-one solution? I don't know.
Yeah, I think the space will diverge into probably two different kinds of architectures. So you'll probably have general purpose architectures like RISC and WASM that will be used, and then you'll also have blockchain specific architectures like the Fuel VM, like the EVM, etc. And basically, I think that for blockchain use cases, it's sort of a no-brainer that the blockchain virtual machines will win, because we can just basically extract so much more performance out of the machine, because it's designed around what we're using blockchains for, which is things like assets, right? So the Fuel VM makes sure that things that need to be first-class citizens are. So things like asset generation, transfers, etc., are native in the virtual machine, which ends up saving you tremendous amounts of complexity in application design, because, of course, blockchains are clearly about tokens. And so basically, if you don't design for that in the machine, it's going to cost you a lot more. Every token on Ethereum is written as an application, even though we don't treat them that way. Like, they're treated like really fundamental mechanisms in Ethereum, but the only actual mechanism in Ethereum is Ether. So Ethereum has just completely missed a huge opportunity to optimize the entire system, probably reduce significant amounts of state and processing, because it chose to basically make tokens applications and not sort of native citizens, native first-class citizens. So effectively, you want to design for what blockchains are being used for. That's going to end up saving a lot of complexity, making it safer, making it cheaper for the user. So I think ultimately general purpose architectures are going to be very interesting, because you can port any piece of code to them. But I don't actually think it really matters, because ultimately the Fuel VM, for example, is as general purpose as WASM or RISC. It's just has a lot more options for a developer to express what they're actually trying to do. So ultimately, it's nice for tooling purposes, but as I explained, the tooling never quite feels right. So effectively, you just can't win unless you really do what we're doing.
Interesting. And I'm curious about, like, piggybacking off that on the value accrual for these types of designs. Like, if you're pretty confident in the blockchain-based or blockchain-specific designs ousting something like a ZK WASM or a separate VM, I'm curious, first, I'm curious as to what your mental model is for the value accrual for VMs. So again, I plug in a transaction, goes onto the operator, Fuel executes it, or insert VM here executes it. It goes down the stack to then kind of like a DA layer or settlement, depending on kind of what the situation is. Then it's sequenced and batched to the settlement layer. And so there's all these different little points there where there's going to be kind of extraction of value for each layer. And so I'm curious, like, what your strategy is for Fuel as at the VM layer to accrue value. And then kind of once we get that down, I'm like, okay, this is how Fuel is going to accrue value in the modular blockchain space. In a world of this many modular rollups using Fuel, we're going to have this many revenue streams from fees from this. Then like, how do we then assess what the value is going to be compared to, let's say, a WASM-based VM or a EVM or a separate VM, and how do we stack up, like how do we do comparative measures of these different VMs? But first, like kind of how are you seeing the value accrue for Fuel and for VMs in the modular space? And then, we can dive into how they stack up.
Yeah, so I think it's probably worth mentioning too, like Fuel Labs as the sort of development company, like our mission, at least as of today, is really simple. It's just make blockchains usable, and that's it. So effectively, most blockchains are not usable, and they are not usable for many reasons, whether it's scale or whether it's security or whether it's the way they're constructed or whether it's just the way that the user experience works because of the way they're designed. So we aim to solve that problem from the virtual machine level up. So basically, unlike most attempts, we solve the virtual machine. We solve blockchain's usability problem by addressing it from the virtual machine upward. And in doing so, you basically provide a platform for people to build off of. And I think an akin model to how to explain value in relation to this is similar to how ARM basically built their model. So ARM, someone wrote 800 lines of code that was the ARM virtual machine so that people could write software and test it. And they spent one night doing it, I think, or something like that. It was this one girl. And around that piece of software that was like 800 lines, they built an entire business around basically that entire system. And initially, it wasn't used a lot, but they found places for where ARM really shined. And in this case, it was like a lot of mobile devices or specialty chips where people needed a lot of specific things. ARM's designs in and of themselves are available. You can view them and download them. They're, I don't know if they're open source, but effectively they're viewable and available. But the infrastructure around ARM is really the kind of core value for it, right? Similarly, the same model applies to virtual machines. So if you have a virtual machine and it's very good and people want to use it or they want to use it for specific things, there's a lot of value in providing the infrastructure around it. There's even more value in the infrastructure around it than just charging fees, arguably speaking, because if you try to build the model around fees, it can't be, in my opinion, it can't be decentralized correctly, but also that should be the role of many different people, thousands of different parties participating in block building. And so you don't want single sequencers to rule the fee game. You want that to be many, many different parties. I also want people to build with blockchain and not have to pay other people's fees, including ours if they don't have to. But I don't want them to have to pay some random layer one's fees if it's not right for them. So ideally, the best way to bring millions of, basically millions of TPS into blockchain from the Web2 world is to effectively solve their issues first and work backward. Not to try to fight for the same $1 trillion in crypto right now that everyone seems to be fighting over, because that's a very insular way to think about it. So our model is quite simple. It's just give people the virtual machine that's really both sustainable, solves all these different issues for blockchain. It's the fastest way for you to complete your business logic, and allow people to pick what level of security, decentralization, settlement, etc. Let them pick and decide what is right for them, right? And then, of course, like Fuel itself, there'll be a lot of different pieces of infrastructure around this, and they'll be very tailored to the Fuel VM and all the different properties and different things we have. And that's ultimately where, I think the value is. So I don't want to speak too openly about it because there's still a lot of designs we haven't released yet. But effectively, the simple answer is just that look at any VM business or, ARM kind of style business. These are effectively similar models. Obviously, Fuel Labs is just a software development firm, but the idea is just that give people the architecture they really need, and then they'll do amazing things with it, and then support them as best you can.
Yeah, it sounds like a version of the FAT protocol thesis at the VM layer, in a sense, the infra, or for lack of a better term, FAT infra thesis, which is interesting. And then if you extrapolate that across however many VMs that you assume will be prominent, the game doesn't become who has the lowest fees or who can extract the most value from the customers. The game becomes who can expand the fastest and kind of perhaps let speculation or let analysts come to their own decisions as for how prominent, how popular, and how much revenue the products and projects built atop of it are generating and how much value they are generating, which is all kind of, again, fat protocol, fat infra thesis kind of trickles down to the VM layer.
I'd also say too that one other aspect of this, which might be important to note, is if you pick a virtual machine that's already widely used and accepted, there's no value, because they're just like, if you pick WASM or RISC or the EVM, that's already a highly available technology that doesn't necessarily independently solve the actual issues these projects will go through. So effectively, it's very difficult to build, I would say, networks around that or ideas around that, because they're already so available. So I think, if you really solve people's problems, it's much easier to build really fascinating decentralized networks around them. One example of this is basically happening with Tendermint and Cosmos right now, where a lot of people are waking up to the fact that basically this project has solved a lot of the real issues of building sovereign blockchains, and they were not really taken advantage of too much because everyone was so obsessed with Ethereum. But now I think as we move more to decentralizing these different layers and infrastructure layers, basically models like Cosmos are fantastic because, or not Cosmos, but more specifically like Tendermint, Comet BFT, and these other architectures, because you can actually build tremendous amounts of infrastructure and network effect around them. So it's a very good moat.
Super cool. And one last thing there, and then Alex has a good question coming up. Is an interesting way that I'm thinking about this is, rather than kind of going with the perhaps status quo of like a WASM or an EVM, you as a developer, you can also make a bet on Fuel, as in, like, if I get in early on this VM layer, or if I'm into something new and innovative and which becomes prominent, and as there's a world where Fuel becomes the next WASM and EVM, where it's like, oh, everyone's already building on Fuel, and then that's down the line, there's something else. But to be in that transition process also promotes like extreme growth from a brand narrative and kind of like overall like expansionism mindset, rather than kind of sticking to what is. So maybe you guys will push Fuel so far and wide that it'll be like don't build on Fuel one day. It's too established already.
Well, I'd hope that basically with Fuel itself, I mean, first of all, it'd be great if it was used that widely. So that would be an excellent problem to have. But secondarily, inherently already, if you look at the Fuel VM specs, we already have ways to extend it. So basically, common design in virtual machines to have like an external call, right? Doesn't do anything. It's like a system call. So the Fuel VM has this, and what that'll allow any project to do is take the VM off the shelf and expand it, do whatever they want with it. Because most projects actually have stuff that they do that would be much better suited to just do versus trying to do through the virtual machine. So think like native level incentives, like all kinds of complex designs like that. Order books at the native level, like all that sort of stuff. So it's very easy for someone to just take the Fuel VM, add the one operation they really want, and then run that chain. And it's already immediately tooled into all the language and all the tooling. And it's immediately interoperable with all the other chains at a scale and high performance setting. So while Cosmos tried to deal with the problems of like the consensus, like building consensus networks, and things like data availability, try to solve kind of this issue of just having the data available for transactions. The Fuel VM really solves this middle issue of you want execution, but you also want interoperability. You also want state minimization. You also want extensibility. You want to be able to extend these things and do what you want with them. So we're solving all of these sort of middle issues that have been really, really tough because people have been so obsessed with either the EVM or WASM or now risk, basically. So yeah, if that makes sense.
Yeah, actually, I like when Andy asks questions, so you can Andy, you can continue. Okay, I have a question about modularity. The main issues of modular blockchains are that they are rather complex and probably they lack security sometimes. Do you think modular blockchains will address these issues in the future, and how?
Yeah, so I think in relation to this, I think there's a few things to note. So one is that all blockchains are complex, and they actually all have significant hairy issues in relation to security. So it doesn't matter whether you're using one blockchain or many, like it's all bad, basically. So we'll say that. The second thing is that even though that's the case, it doesn't necessarily mean that it's worse per se to use multiple blockchains to solve different problems, depending on how it's constructed. It does introduce, though, more assumptions around what needs to be right in order for this system to work. So if you're building on Ethereum right now, you just need to assume Ethereum will work via the honest majority of the consensus, and that's it. But if you add in external DA layers, well, now you're adding in another two problems. One is the bridge between that system and, say, Ethereum. And the second thing is you're adding in another honest majority assumption around that layer. Now, while honest majority, and we haven't really seen networks be totally taken over. Sometimes it's happened, but usually on like vaporware chains, etc. Now you have two honest majority assumptions, and you have a new failure fault, which is the bridge. Similarly, if you add in additional things like shared sequencing, which is doing other parts of the process, that could also be not necessarily as much of a security risk, but definitely as much of a usability risk, right? If that doesn't work well. So really, I think that yes, these stacks are complicated and they're not nice to build with, but I don't actually think that's going to stop anything. I don't think that really matters. I think everything's complicated and engineers typically figure it out. It's really sort of what properties are you willing to accept and what is right for each project. So, if you're a gaming company and you already run a point system inside of a server, that's your security model. You don't care. You don't care about all this other stuff, but you have millions of TPS just sitting there in your system. So what's right for that company might not be right for someone building a DeFi app, right? And so basically, you have to look at this as modular will win because it offers a more defined spectrum of options that you just can't get if it's a single monolithic chain. And quite frankly, there's a lot of companies out there that don't like crypto and they don't want to pay the fees of some monolithic chain. So you better start designing around that if you really want to solve their problems. And so from our perspective, all of that complexity will get shielded away. And as well on the user side, because of properties like better virtual machine design and better introspection, a user is not going to notice if they're moving between fuel chains. It'll be almost as if you're on one chain. And between that and things like intents, we basically wholeheartedly solve the issue for users to such an extent that they'll never notice. And you'll inherit incredible security if it's designed well. So basically, all those problems go away. They're just engineering issues. And quite frankly, building everything on a single network has never worked in history for any kind of network ever, because of physics, and also because we don't want to do that, because then the network itself even becomes a point of centralization. And we've already seen that happen with Ethereum staking. I would not want to put all my eggs in one basket, as well, in the sense, without having really significant guarantees around it. Yeah.
Yeah, and very good points all around. And I think the complexity is a risk worth taking from the builder perspective. I mean, clearly, I think Modular is the biggest narrative for 2024. It's funny, man. I've been in the space for 3 years, been doing DeFi education since freaking yams. And I was at ETHCC in Paris this year, and I faded Modular Summit. I'm going to go to Dale 2 days. Now I'm like, wherever there's Modular, I'm there. And like I tend to be, because of our education, we tend to be quite early to like the new thing, and so that's still like where we're at in the education and like awareness cycle. So I think you have some time to keep building and kind of position, which is really good. And then kind of on a more technical level, going back to what you were saying earlier, well, with regards to light clients and just kind of this idea of this light verification of the fuel VM, and kind of how I kind of pointed to data availability sampling with Celestia and Avail and insert DA layer here as to how they do that. I'm starting to realize like a lot of the complexities in Modular that are caused by the interop of different code bases being kind of stacked together. The trade-off per se is that we are kind of evading the typical trilemma trade-offs by using light clients and these lighter solutions to solve the problems of the trilemma without kind of having to fully accept it. So like in the VM example, you're able to offer lower cost, faster execution, better developer experience, amongst other things, compared to EVM because of that model you spoke of. And again, on the data availability layer, it's much cheaper because they only have to cryptographically prove a couple proofs within one set of or one blob, for lack of a better term, and then boom, it's way cheaper. And so I'm starting to realize a lot of this modular stuff is all about trying to figure out how to solve this typical blockchain trilemma that comes with a monolithic chain, by using these lighter forms of verification or different ideas around security with, basically ZK or light client-based proving systems, which then gives you a more efficient system and cheaper. I don't know. Any thoughts on kind of like the efficiency and yeah.
Yeah, for sure. So I'll start with saying that light clients don't solve everything. I mean, they certainly solve a lot of things in terms of just getting a pretty good proof of things happening, of certain things happening and occurring on chain. Light clients do have limits, though. They don't necessarily check the entire state of the whole chain. So they don't really know if the header they're looking at is actually valid. So in a sense, they're good to basically get I don't want to say probabilistic, but they're good at getting a certain degree of certainty around what's happening. Much better than just trusting a third party to tell you, right? So basically you're trying to solve this issue of, I don't want to just trust some server. I would rather the server provide me some evidence that this thing that I'm looking at is what it is and is probably good to interact with. So light clients really solve that, whether it's data availability sampling or whether it's introspection from like a fuel block header down to the transactions. Those are really good pieces of evidence for just understanding what's happening within a blockchain. And I would say, though, that it still comes down to, unfortunately, what is the node requirements to run the entire chain and validate the entire chain. And that still, for me, is pretty much your ability to assess decentralization, to assess how secure this network is. And as well, it's not just that like light clients are good for that. There's another issue with a lot of this stuff, which is that you need to provide the infrastructure for it. So a big reason why people say, oh, I'm going to go with this monolithic chain because I don't deploy a blockchain is because of the way those blockchains are designed. They were never designed to be tooled. They were never designed to be built around infrastructure, and they're really costly to run. Like to deploy a rollup right now, an EVM rollup, because of how costly it is to run everything around it and how hard it is to introspect. It's incredibly costly to run all the infra around it, right? And so when you design for all of this, when you start and you design for more sustainability, you design for better execution properties, you can run blockchains on very low node requirements with very high TPS, still have incredible properties of verification with full nodes, and have the incredible properties of light client verification across your whole network. So basically, node requirements for full nodes is extremely important. Unfortunately, many blockchains have set their bandwidth requirements, in my opinion, far too high. Like, for example, 1 gigabit bandwidth connection is crazy to me in terms of a decentralized network. Basically, I have yet to be on an internet connection in any of the settings that I move around in that has hit that bandwidth requirement. The only settings you can hit that with are in financial districts and in T1 lines, or if you're in a server farm, basically. So in my opinion, my hesitation around some of these other newer layer ones to service and move blockchain forward is that they set their node requirements too high. And you might think like right now that's not really an issue and they'll give you 5 reasons why it isn't, but it is. And it's a huge issue because that means that now you can only run blockchains on commercial property, which means that your blockchain is only as good as the commercial laws of that country. And they remove you from very important protected expression laws that a lot of countries have that a single individual would have. So basically, the reason why I like Ethereum a lot versus even newer networks is because Ethereum has very low bandwidth requirements and light clients. Now, we don't use the light clients because the design of the system is not very good. But basically, I think that blockchain really needs to take that into consideration. Other earlier blockchain people did really significantly. And whether it's like Bitcoin or Ethereum or even the Cosmos community and Tendermint community, like they really did. The newer blockchains that just want to go like high TPS, unfortunately to me, are not even decentralized enough to call a blockchain network. So it's too high of a requirement. Yeah.
Yeah, that's the problem with them as a settlement layer. That's why I'm super bullish on Ethereum as a settlement layer for a long, long time. I think there's a bit of a narrative that like these new VMs and new DA layers are going to cause problems for Ethereum's dominance. But to me, it's like Ethereum switching from a computational roadmap to a data roadmap. And so they're going to, with base rollups, Ethereum will stay dominant in DA, even though Celestia and Avail and et cetera will have their chance to shine. At the VM level, I think they're like that's EVM's kind of on its way out, but that's fine because as long as Ethereum can kind of maintain the settlement and DA components because of this distributed validator set that you kind of speak about, because of this lower node requirements, and especially with like things like DVT coming out big time in 2024, that starts to get extrapolated even further. Solana's kind of an edge case. They have more than 2,000 validators on the monolithic side. There's very interesting comparisons to be had between modular chains and Solana. I'm very excited to kind of draw upon that narrative next year and try to really like pin up some modular stacks with Solana and really kind of address the pros and cons there. I think that's kind of an exciting one. And then I think like the aftermath of this validator of this node requirement conversation with the modular stack, it comes into like, I think for me, it's like this misalignment of state problem with modular chains. And if that's a huge risk where you have all these different kind of parts to a modular chain that is that is on one settlement layer. And obviously with centralized sequencers, it's kind of, it's really kind of low risk to have a state problem. But once we decentralize that a bit, like, is that a huge fear of modular builders? Is missing and messing up the state and not being in alignment with the L1 a big problem? Or like, as we're kind of wrapping up, I'm curious, what is the biggest fear or problem for the modular stacks that we're going to face that perhaps monolithic don't, because it's all in one? For me, it's like this misalignment of state problem where like our blocks get all messed up and the chain is basically catastrophically affected because it's not in alignment. But maybe you have a different perspective.
Yeah, I mean, I think in terms of fears, I don't actually have too many for the stack itself. I think it's the right architecture because you'll have the most amount of parties doing as many different things as possible, which is excellent for security properties and decentralization. So if we really want to build incredible decentralized networks for the world to use, right, in a very permissionless way that help people that maybe like aren't in the best situation with their government, or, basically can provide a different level of financial services to the world that we just currently can't access given the way things are built, I would say that this modular approach is much better. Having more options, more different kinds of things to experiment with, they'll harden, get more secure over time. The main things that people need to look out for is just that, like, basically, there's probably only going to be a few blockchain architectures because they're extremely, as we've learned, at least from building Fuel, extremely resource intensive to produce, like just the architecture and all of the tooling, related tooling itself. So there'll only be a few architectures, really. We'll learn the different properties of how to interoperate them and build with them. But basically, monolithic design is dead. Like, it's completely dead in the water. The reason why is because it doesn't foster enough creativity.
Solana, though, man.
That will.
I think Solana could compete with Fuel VM modular chains.
So the thing is, in the end of the day, it won't, because with the Fuel VM itself, we'll just be able to produce so much more TPS than Solana that a single chain would never compete with that. So basically, the aggregate network of Fuel rollups will always be more powerful than a single monolithic one. So I'm not actually concerned about that. And with better and more interesting designs, right? Like, just more interesting stuff can be done with it. So I would say not too.
I wouldn't expect you to back down, brother. I'll tell you that.
We'll put it in a headline, like monolithic design is dead.
Yeah. It would be nice. Very much is. at least in my eyes. Yeah.
Nice.
Cool.
I guess I have one last one. I think Alex is gonna have some like bang ones. I have a quick one too. What is like an under or a lesser known part of the stack that is super important? We have DA, VM, settlement, sequencing, and interop. I'm kind of trying to like push them into the stack in 2024 and like start to brand narratives around those two as part of being in the modular stack. But like, are we missing something that we need to think about and that will be an emergent narrative of the stack, sequencing or interop? Is that it, or is there something else that we need like that will come onto the landscape that is like, oh, this is now part of the stack too?
I think every team working on a stack design holistically, like wholeheartedly, is doing some form of sequencing and interoperability idea. So if you're using ZK, you're spending enormous amounts of money, you're producing a proof. The proof can then be used for interoperability because you can basically take a look at what's happening in different chains, right? So you get a really nice view of what's going on. With things like the Fuel VM, because of the way we've designed it, you don't need ZK. You can just take a look at it with some Merkle proofs. It's very easy. So you don't really need that. But ZK is very, very interesting. We use it for our proving model and a bunch of other things. So basically, I would say that interoperability and sequencing is going to be definitely a big thing, because that's how people can build networks of chains that are, more interesting than just a single rollup. But I'd also say that there's some other things going on here where, in building all these new chains, everyone's going to have now more infrastructure to support and more state to deal with. And the overhead and the sustainability properties will really start to play in terms of the pressure they're going to put on everyone's system. And so I'd argue that state growth is actually one of the biggest issues of blockchain, existentially speaking. And Fuel is actually one of the only chains that really addresses that. And as well, I would also say that basically introspecting the chain or taking a look at it and indexing it is pretty much most of the work.
The RPC
and if your architecture is not set up to effectively handle giant amounts of RPC and also very intense indexing, then you've got a big problem. So the Fuel VM and the Fuel app itself, the back end of each app is an indexer. So we design everything to be run locally, to be run on normal consumer hardware. You'll never have this like thing that affected with Ledger recently, where you get some kind of weird injection going on and like that kind of thing. Everything could be rerun locally. You could run your local terminal with all your trading and swapping apps, everything verified, everything, in a nice way, very light to run. So basically, we're just designing a completely different sort of system to what's out there in terms of architecture.
Avail's doing the same thing with their light clients and their DA layer. They've been working like a year and a half on solving the RPC problem without needing custom RPCs for all these different chains. That if they're all Avail-based DA chains, they can all interoperate with each other through kind of like a general message passing layer or like an information layer. Again, I'm not fully up to speed on the tech side, but more or less, like I think this like data indexing part of the stack could be part of it, or like you said, with Fuel, it's just going to kind of be embedded into either the VM or the DA layer or both.
Yeah. I think these are really the interesting properties to explore right now, that are definitely not talked about so much. But basically, everyone's planning on having a single rollup, and they're just dealing with the realities of that. And that is basically the smallest, value potential that there is. The biggest stuff is trying to build execution layers that people feel comfortable using, for all different kinds of projects, and then bringing that into blockchain. So I think that's really the bigger scope. And that's, again, why monolithic design just won't work. And all these other architectures were designed for monolithic chains, whether it's Move or whether it's like the EVM, they're all monolithic architectures. The Fuel VM might still be probably one of the only actual roll-up designed architectures. So it'll just be, there's no second best.
I like the conversation very much. I have a lot of questions, but I think we're running out of time. So we need to wrap up. So yeah, I think that's it. Thank you so much, Nick. You covered a lot of interesting stuff. Thank you, Andy, for beautiful questions. You helped a lot. I think today. Yeah, I even understand most of the things you were talking about. So yeah, I think that's it.
Thanks,
awesome,
guys.
Well, thanks for having me. Really great.